Hello and welcome to the webinar on programming with GSA APIs. My name is Ramseshan Kannan and I'm a member of the GSA software development team. I develop and maintain the COM interface related features in GSA. So let's look at what the COM interface is about and what we can do with it. Following few slides. Right. So it's always good to start with a motivating example. So I thought, why not create an imaginary scenario where one has to do a repetitive task in GSA through the interface, and I thought, why not demonstrate how the API makes doing that task possible without having to open an interactive session. So let's say that we've got to create a sinusoidal roof form in GSA, which is, let's say it was part of a roof specifications. So what we would do is start with, wait till we catch up. Still catching up, right. So let's create a few nodes. Create a node at y10, sorry, join them with an element and copy over this element a few times. So let's say 0.5 meters, right, and we now got to stitch up these nodes. So let's go to 1D element operations, add 1D elements, and that gives me a bunch of nodes there. I think I'll need elements, I meant there. I'll need some more elements on the top, so we do repeat the same operation at the top as well. So what we've got here is a flat roof. How do we transform it into a waveform? Select nodes, and one of my favorite functions in GSA, transform geometry, to the rescue. So what this takes is it can evaluate any mathematical expression and feed them into the XYZ coordinates of the nodes. So I'm going to keep X and Y the same, but the Z coordinates would be, let's say, 4 times sine of X over 4. And let's see what that gives us. Right, so that's what we end up with. And in the real life roof will not be as simple as that. But imagine if we had to do the same thing programmatically. We'd have to write a few lines of code like the one I have here. So open a new GSA model over here, and the XYZ coordinates are the Y coordinate. I'm sorry, the Z coordinate is the sine of the X coordinate times scaling factor, and then create nodes at N1, and then add 10 to Y and create a node again, and then stitch them up with elements, and then stitch them across with elements, and so on, and then iterate this over 100 times. And if I were to run this, let's put a breakpoint here, and I've saved this model as demo.gwb. So if I were to run this example, So that's finished executing. Let's try opening the model. So we got comp tests demo.gwb. So that's given us something to a similar effect. Of course, if we were to then ask to change the amplitude of the sine wave, whilst in the interactive session, this will require rework of the entire model. In the comp script, all we'll need to change is just a parameter here, the scaling factor, and we're good to go. So that's a very sort of synthetic example, but the idea was to tell you what could be done with COM APIs and how a routine repetitive task in the UI can be automated using a script. Okay, so what's the presentation about? So we'll go through a quick introduction of the COM APIs, what they're about, state the assumptions for the scope of this presentation, then go over the elements of the API. The word API, by the way, stands for Application Programming Interface. It's a software developer jargon for any library or a set of functions that allow you to invoke a functionality bundle within that library or the application. So an API would be something that you could call from within your program or your script, and that allows you to execute some pre-written code in some part of the library or the application. How do we use the COM APIs in GSA? What documentation is available? And we'll end with some examples and case study from Peter. All right, so what are GSA APIs? GSA APIs are an alternate route to access the existing GSA functionality. What that means is they just extend the current GSA functionality so that you can invoke them programmatically. They don't add any new functionality. You can, most actions that you do interactively within a GSA session, for example, sculpting nodes or extracting results, can be done using a program or a script. The way it works is, instead of you sort of sending commands to GSA using the user interface, you poke it through your program, and the program in turn fetches either sort of sends the commands or fetches the results, as it were. So that's what APIs are used for. They can be used for, in fact, anything that you want to do interactively within GSA. So sculpting models, extracting results. You can extract steel utilizations, create your own program for sizing members on the basis of steel utilization results, and also change member sizes iteratively. It can be used for creating plugins to 3D modeling packages like Revit or Rhino that exports or imports a GSA model into the 3D modeling package. Where can I access this functionality? Well, by definition, because COM is a remote a feature that allows remote access to GSA, you won't find any reference to COM within GSA except for in the help file. So to be able to access this functionality, we need to write a program that makes use of the GSA COM object. And within the VBA environment, for example, that comes with Microsoft Office programs, this could be done by adding a reference to the GSA type library, and then invoking the GSA COM object from within your program once it knows about the type library. How do I get started? Well, that's what this webinar is about. You will need to get started, we'll need to, as I said, write a program that makes use of the GSA COM object, and before that, instantiate the object and then call the functions. that the object exports. But before that, we'll need to make the program aware of the COM object. And here is how we do it in VBA. So under Tools References, add a reference to the GSA 8.5 type library, and then the under Object Browser, the COM auto objects becomes available with the GSA 8.5 type library, and these are the functions that the COM auto class exports. We'll look at these more closely. Right, so the assumptions for the scope of this presentation are that we assume a basic understanding of programming. So when we look at code samples, we'll assume that the listener knows about how programming works. We'll use VB.NET for our examples, although everything that we discussed or we are discussing in this presentation can also be done with VBA, but personally I feel that VB.NET is a better choice if you're starting programming as of today, because it offers a better software development environment, richer libraries, better debugging support, object-oriented programming support, and also it's easier to sort of share code with others when you write it in VB.NET or C# as opposed to Excel VBA, where the code is logged into a spreadsheet and it's difficult to pass it around modularly. VB.NET code can be written in it can be written in any text editor, but to compile and run it, you will need an IDE, and Visual Studio is what Microsoft develops, but it's not free. You need to buy a license for that. But Microsoft also develops something called Visual Studio Express Edition, which is a stripped-down version of Microsoft Visual Studio, and it's available free of cost. In fact, I've got the website open here. So that's the Visual Basic Express website on Microsoft.com, and I believe it's a stripped down. It's got almost all features that Visual Studio has, except for things like documentation, which can be accessed easily on the internet anyway. Right, so that's Visual Studio Express. So what I was trying to say there was, even if you didn't want to buy Visual Studio, the actual Visual Studio development environment, you can still start your development with Visual Studio Express and take it from there. The scope of this presentation is that it just covers a gentle introduction to COM. It will tell you what the COM APIs are about and what can be done with them, but it's by no means a detailed tutorial, or it doesn't sort of replace reading the user manual and so on. Right, so elements of the COM API. I think I forgot to mention earlier on that the GSA APIs are presented through a technology called COM, which is a Microsoft sort of proprietary technology. It stands for Component Object Model. And what that means is it's a Microsoft way of it's a facility by which any software can make its functionality available to for programs to invoke it remotely without opening an interactive session. So that's what the COM functionality in Windows allows you to do. So the GSA APIs are made available over this COM subsystem, and the GSA COM object, which is called COM auto, as we saw in a few slides back, it consists of a bunch of functions which are logically grouped into families. although all these functions are available on a single object. So these functions can be sort of grouped in families depending on this kind of functionality they offer. So core functions are to do with opening and closing of files, saving models, analyzing them, and so on. View functions are to do with enumerating views, saving saved views to file and printing them. Data and tools functions are to do with manipulating or creating some entities within GSA, for example, nodes, or for meshing regions, or for querying member element relationships. The data and tools functions work only with a subset of the GSA data. So you can't kind of create any object, every object with the data and tools functions, and we've got the GW command for that, which I'll come to. Case and task functions are to do with analysis cases and analysis tasks. Enumerating analysis tasks, querying task case relationships, querying if a particular task has results, deleting them, and so on, and also analyzing tasks. List functions are, as the name suggests, they deal with GSA save lists, querying whether an entity belongs to a list or not, enumerating save lists and their names, how many lists you have in the model, and so on. A GW command and output functions form the bulk of the API. So GW command is actually just a single function, but through the single function we enable the use of we enable working with almost any part of the GSA model, nodes, elements, properties, loading, any entity that you might, or any property that you might create in GSA interactively can be created or edited or even deleted using the GW command. The way it works is it takes as an argument a string which is in a particular syntax, and if you're familiar with the GWA text file format in GSA, which is the ASCII based text file that we have, you might have seen that it has a particular format if you opened it in a text editor. So let's do that straight away. I'm going to save demo.gwb as a text file. Okay, and open it from here. Oops. Right. So we've got the nodes table here, and you can see that they are in a particular format, tab separated, and the index and a few other parameters. These ones look like the coordinates to me. So where do we get this format? Well, this is documented in a file called gwa.html, which is located in the GSA program files folder under docs gwa.html, and this gives us the format for all GWA keywords. So we've got an index here, and if we look at nodes, so a node needs a node number, the name of the node, color, and the XYZ coordinates and other parameters. So a GWA command takes as an input one of these strings, and with these strings you tell GSA what kind of entity you want to work with and what you want to do. So you can either set an entity or get an entity, and if you get an entity, it returns a GWA string in it returns a string in the GWA format. If you want to set a string, you need to supply it a GWA string, a string in a GWA format. You can query other things like the highest node and highest element, and there's a format for that as well, all of which is documented in both in gwa.html and in the help file. So how do we, right, so this file gives us, given a keyword like node, it gives us the description, i.e. what the keyword stands for, and then the parameters, what each of these parameters indicate. But how do we go how do we go the other way around? So if we want the GWA keyword for example, loading, how do we how do we find out the keyword? So for that, I often use a feature in GSA that's called the gateway copy paste. So if I want the keyword for section properties, let's say I've got a beam element here. Let's create a dummy element. I'm sorry, a beam property here. Let's create a dummy property. Now I can copy this data onto the clipboard, and if I go to a text file and I paste it here, what I get here is a string that that stands for the data that we copied. So by sheer coincidence, this string happens to be in the GWA format. Well, actually it's not coincidence, it's just that we use the same GWA engine for various features within GSA. So for example, copying and pasting data, or for the text file, or indeed for the GW command, as you've just seen. So the string that we have here is actually in the GWA format. So if I copied a section property and look at the first keyword in this string, it gives me the actual GWA keyword. So propsec is the keyword for the section property entity. And if I look at propsec in gwa.html, right, so that's what it looks like. We've got the number of the section property, name, color, material, description, cost, and other parameters. Right, so that's how you would go from an entity to a keyword. So given a keyword, we can find out what syntax it follows, and given an entity, we can find out what keyword it relates to. And using both these pieces of information, we'll need to construct a string that has all the relevant bits of data, and then pass it as an argument to GW command. We'll go to an example very shortly that will make the usage clear. Output functions are to do with output for extracting results and output data from GSA. So having analyzed a model, you may want to extract the nodal displacement, or the element bending moment, or the steel utilization. So output functions allow you to extract any results that's made available through the tabular output format in GSA. So in fact, whilst the GWA command is analogous to the GWA text file format, the output functions are sort of, they have one-to-one correspondence with the tabular output format in GSA. So if I were to look at a model that's analyzed, if I want to look at the nodal displacements, if I say A2 and node 2, right, so I selected node 2 and analysis case A2, and it gives me the all available results for this node for this particular load case, and I can look at the X translation, Y translation, and so on. So output functions work in pretty much the same format. We initialize output functions for a particular load case and for a particular result type. So X translation, for example, and then we can query the result for every given entity that we can that we supply to it. Again, we'll see an example shortly. So if, for example, we had a simple task, if we wanted to, given an existing model, we want to apply a load on the beam. We want to create a point load at the center of the beam, and we want to, over here, and we want to analyze this model. So how do we do this in COM? So what I've got here is a piece of code that I wrote before this presentation. I'm going to copy this code, and I'm going to go to Visual Studio. I'm going to start a new project. Let's choose a console application, Visual Basic console application, and say OK. So it has left us with a main function where we can write our code. But before that, we need to add a reference to the GSA COM object. So let's say add reference, and then I browse to the GSA program files folder. And add a reference to a file called interop.gsa8.5.dll, and that's nothing but a wrapper to the gsa.tlb, which I can also use to add a reference to. The interop.gsa8.5.dll is actually a wrapper meant for .NET clients, for .NET COM programs. So if I add a reference to that file and I go to the object browser, it now shows me a tree for interop.gsa 8.5, and if I click on the COM auto class, I can see all the functions here. So that means that my program now knows about the GSA COM object. So these are the output functions over here, and there's some tools functions down here and so on. So if I now go back to the main function and I paste the code that I had copied earlier on, just compile it. So that compiles okay. I'm going to put a breakpoint here to know if when it's finished running, and start. Before that, I think we'll need to ensure that there was no load on the beam that we want, that we are interested in. So it does have some loading, so let's get rid of that. Oops. Right, so that's gone. Save the model and close it. Close all this. And I run this sample. That seems to have run. Close it and go back to GSA to see if it has done what we wanted it to do. There's a model layer. Yes, so it has created that load at the center, and if we turn on the bending moments, it seems to have analyzed the model as well. So that's what we wanted to. Let's take a closer look at the program. So what we did was we first instantiated the GSA COM object using this line. We just created a type of GSA 8 underscore 5.com auto object and named it GSA obj. We then opened the file from this paths by calling the open function, and then we deleted the results from the file, and then we want to create a point load at the center of the beam. The element number is 2, as we can see from the model here. So what we did was we need to find out what keyword pertains to beam point loads, and we can find that out using, say, copying pasting from the gateway. So we know that load beam point is the relevant keyword. We then go to the gwa.html file and look at load beam point. So it takes a list of elements. Well, the description is beam point load definition, so yes, we are looking at the right keyword. It takes a list of elements, the load case that the load pertains to, the axis on which axis along which the loading is to be applied, whether it references the global axis or a user-defined axis, whether the load is projected or not, and the position of the load and its value, position along the element. So that's what the GWA syntax for load beam point looks like. We can put this. So each of these pipe characters in this syntax can either be a comma or a tab. So we can separate each of these fields using commas and create a string, assemble a string from these parameters, and then pass it as an argument to GW command, which is what we've done here. So we created a load beam point for element 2 belonging to load case 1 along the global axis, and not projected along the z direction with the magnitude at 0.5, which is at 50% of the beam lengths, and the magnitude is -3, which is 3 newtons, I think 3 kilonewtons in the minus z direction. Analyze the model by calling the analyze command, save it and close it, and then set the GSA object to null before exiting the program. So that's all that's needed to achieve that fairly simple task, I must say. But that was to demonstrate that getting started with writing a COM program is quite simple. All you need to know is a basic set of commands, and then you can build from there. Right, so but obviously what you might be wanting to achieve with your COM programs might be much more sophisticated. So we've got plenty of documentation in place to be able to use these functions to their fullest capacity. So the help file in GSA, I'll browse to it now, contains a whole section on COM programming, which you can find under Programming in Command Line Interface, COM Automation, COM Export Programs. So the COM Automation section contains a little bit of information about things like early and late binding and the differences, and how to sort of invoke GSA in a version-specific manner and stuff like that. The COM export functions are the COM family of functions that we were discussing some time back. So the each of these functions come with documentation for the argument types, what the arguments stand for, and the return types, and what the return values indicate. So calling and the analyze function takes the data type long as an argument and returns another integer as a return value. the argument stands for the analysis task number, and the return type number depends on the result of the analysis. So if it's 0, then the analysis went okay. If it was 1, then there was no GSA file open, and if it was 2, then the analysis failed. Right. We also got the gwa.html file that documents the GWA format. We've also got another file called output_dataref, which sits parallel to the gwa.html file. I just browsed that. So under the docs folder, we've got output_dataref.txt. And this file contains enums for the result types that need to be supplied to the output family of functions, and I'll just come to that in a moment when we look at these samples. So the samples, there are 3 types of code samples that come with that are installed with GSA. You've got a C++ sample, which is a fairly simplistic program that opens a file, analyzes it, and closes it, and it just demonstrates the use of the GSA COM APIs from a C++ program. The VBA sample consists of a bunch of sheets, each of which demonstrate a particular functionality in the API. So the samples can all be found under this folder API and GWC, and the VBA sample in particular is in this Excel file here. It's called GSA COM GWA sample.xls, and each of these sheets stand for they demonstrate the use of a particular aspect of the API. So print or save views, as the name indicates, works with the views family of functions. Case interrogation works with the cases and tasks functions. Version check checks the version of the GSA program that's currently installed on your machine. Remote interface works with GWA command. So this is again something that I find very useful as a development tool, because when I'm writing my GWA command syntaxes, I often need to verify whether my syntaxes are correct. Despite having access to the gwa.html, it's easy to make mistakes while working with the GWA syntax. So I use the remote interface spreadsheet to also to sort of cross-check my GWA syntaxes, but to also see what a particular GWA syntax looks like for a subset of the data that I'm working with. So if we look at the demo.gwb file that we saw earlier, open the file, and if I pass the command get L2, I'm going to delete this for now. I got a result back which looks like this. So what it has given us is the result of the function call get lm2, which is to get the element number 2 in the GWA format, and it has given this string back, and you will recognize that this is in the GWA syntax format. So L is the keyword for element, 2 is the element number, and 1 and 3 are the topology nodes. So I use this spreadsheet to verify my GWA command, so it's quite useful while writing COM programs. The output spreadsheet, again, it extracts output from GSA models. It demonstrates the use of the GSA output family of functions. So it takes, let's delete all this again. It takes the analysis case and the node or the element reference, and it takes an integer, which is a 6 or 7 digit integer, which is the sort of the enum code for the result type that we want. So if we want the white translation for the node, we need to supply an integer that corresponds to the white translation, and that's where the output underscore data ref file comes handy, because it documents all the enumerated values for the result types that GSA has available. So if we want nodal results, and we want the white translation, which is there's a little bit of guesswork here, but the names are sort of quite suggestive, but sometimes they're not. So the disp underscore dy stands for white displacement, and we can in fact cross-check this. But firstly, we need to sort of calculate the right code. So the ref disp is the header for ref disp dy. So we need to add, in order to get the value for ref disp dy, we need to add the offset from the header. So the header is at 1200 and 1000, and the keyword that we are interested in is at offset 2 from the keyword. So we need to add 2 to 1200 and 1000. So that's 1200 and 1002. And let's modify this to 2. And we're hoping that this is the keyword for the white displacement, and we can find out by running this sample. If I've opened the file now. Oh, incidentally, using the COM functionality doesn't, it's not necessary for you to keep a GSA session open. If you don't have a GSA session open, your COM program will invoke GSA in the background. You will never get to see the GSA window. But if you do have a GSA window open and you run a COM program, it will try to hook into the existing GSA session. So you might see your model being opened and closed within the existing GSA window, and that's perfectly okay. So if I hit the output button here, it's told me the title for this particular keyword. So the result type title for this keyword is translation UI, which is what we are after, and it says the value is 0. So if we want to look at analysis case A1 and node 2, and we see that UI is 0 over here. So that's what that was giving us. So we can play around with various data refs from this file, various result types, to check if the result type that we want is indeed the one that we guessed from this file. And that's where I find this spreadsheet useful. Okay, so moving on, we also got .NET samples. So the GSA installation folder ships with a .NET sample that's called the GSA COM util, and it's a class, but it's also a wrapper class. I'll need to introduce what I mean by the term wrapper. A wrapper is something that one might write to a piece of code that one might write to simplify the use of another library or another sort of API. So in this case, you might want to write a wrapper to simplify the use of the GSA COM APIs. So there's plenty of boilerplate code that's involved while invoking GSA COM. There's plenty of code that you might want to isolate and sort of keep isolated from the rest of your code, because you don't want to change all of your code when something changes in the COM APIs. So for example, you might want to create specific functions that work with the GWA command keywords, and you might want to sort of keep them separate from isolated from the rest of your code, because changes to the GWA keyword will not affect the changes to the rest of your code. So a wrapper class is useful in all of these situations. So if you create a class that wraps around say functions for creating beams and nodes and such common entities, you can then put them all together as a package or a class, and you can and in fact you can even redistribute them or share them with your colleagues, because there might be lots of other people who would want to write the same functionality. So that's just reusing someone else's code without reinventing the wheel. So the .NET sample actually demonstrates how such a wrapper can be written, and it also contains a reference implementation to one such wrapper, and it wraps around a small subset of GSA entities, things like querying highest number of elements or lines, or creating areas and section properties and so on. So that's what the .NET sample is about. There's also another .NET sample in a library called DesignLink. DesignLink is an interoperability toolkit that has been developed by Arup. It's the source code for DesignLink is actually available under a collaborative agreement. It's available free of cost, subject to signing of the collaborative agreement. And the DesignLink library can work with various file formats of softwares that are used within the AEC toolchain, and GSA is one of them. So while working with the GSA formats, it uses the GSA COM APIs to read and write data, or indeed to sort of control GSA remotely, run analysis and stuff like that. So we've got various functions to, as you can see in this screenshot, various functions to read and write loading, for example. So the DesignLink library is available from this URL here. It's worth sort of looking into because it contains a good implementation to a GSA wrapper. And right, so where are we taking the GSA APIs in future? Well, we've got two sort of within the medium and within the short term and the medium term. We've got a bunch of enhancements that are planned. Within the short term, within the 8.6 or 8.x family of releases, we'll be making some minor enhancements to the present COM APIs, making them adding a few functions that make it more convenient to work with things like views, adding a few functions that help you extract a set of results as an array rather than as single quantities. So those are things that we are adding to the present COM API, so that it makes it more they become easier and more efficient to work with. But for the medium term, for the GSA 9.0 family of releases, we have plans to sort of revamp the entire APIs and make them available as .NET based APIs. And what that would mean is we'll get a new object model that's cuter and more elegant to work with. So if we want to query nodes, you'll be able to extract the node object out, and then query various attributes on it, or edit some of them and reinsert it back into the database, instead of having to work with GWA syntax, for example. So those are the kind of things that we have planned for the .NET based APIs that we might release in the future. And of course, we can also have more COM-based training if there is interest. So if you are keen on such training, please let us know by contacting us on email. Right, and for the case study, I'll now pass it back to Peter, who will take us through some examples of where the GSA COM functionality has been used on live projects, and certainly some of them are very impressive. Thanks.